Lara Paralejas.
And I am Jeremiah Mendoza.
We are here to discuss to you the limits of a function using tables and graphs. Rationale. The purpose of making this video is not only to comply but also to help others, educate them, and improve their skills about the said topic and in calculus. Objectives. At the end of the video, the learner should be able to identify the limit of the given function using table of values and graphs, and identify if the limit do or do not exist using graphs. Introduction. The limit of a function is a fundamental concept in calculus and analysis concerning the behavior of that function near a particular input. We say if the function has a limit L at an input P, this means f of x gets closer and closer to L as x moves closer and closer to P. More specifically, when f is applied to any input sufficiently close to P, the output value is forced arbitrarily close to L. On the other hand, if some inputs very close to P are taken to outputs that stay fixed distance apart, we say the limit does not exist.
Sample problem. Example number 1. Evaluate the given function using a table of values. The limit of 2x plus 4 as x approaches 3. To evaluate using a table of values, we will substitute values that are approaching but not equal to a particular input. For this example, we will use values that are getting closer and closer to but not equal to 3. This will show the behavior of the function as it approaches the x value. First, let's find the limit of the left-hand side of the function, or the behavior of the function as it approaches the x value from the left. To do this, we will substitute values that are less than and are approaching the x value. For this given, we will use values that are less than and approaches 3. To evaluate, let's use 2, 2.5, 2.9, 2.99, and 2.999 as the x values to be substituted to the function. Keep in mind that these numbers are arbitrary. As we can see from the table above, the function f of x approaches 10 as the x value approaches 3. Therefore, the limit of the left-hand side of the function is equal to 10. Next, we find the limit of the right-hand side of the function, or the behavior of the function as it approaches the x value from the right. To do this, we will substitute values that are greater than and are approaching the x value. For this given, we will use values that are greater than and approaches 3. To evaluate, let's use 4, 3.5, 3.1, 3.01, and 3.001 as the x values to be substituted to the function. Keep in mind that these numbers are arbitrary. As we can see from the table, the function f of x approaches 10 as the x value approaches 3. Therefore, the limit of the right-hand side of the function is equal to 10. A limit of a function exists if both its left-hand side and right-hand side limits exist and are equal. Otherwise, the limit of the function does not exist. In our example, the left-hand side and right-hand side limits exist and are equal. Thus, the limit of 2x plus 4 as x approaches 3 is equal to 10. Evaluate the given function using a table of values. The limit of ln 3x plus 1 as x approaches 2. To evaluate the given function, let's first find the limit of the left-hand side of the function. Based from the table, the function f of x approaches approximately 2.792 as the x value approaches 2. Then, we find the limit of the right-hand side of the function. Based from the table, the function f of x approaches approximately 2.792 as the x value approaches 2. For the given example, the left-hand side and right-hand side limits are both approximately 2.792. The left-hand side and right-hand side limits of the function exist and are equal. Thus, we conclude that the limit of ln 3x plus 1 as x approaches 2 is approximately equal to 2.792. For example number 3, evaluate the given using a graph of the function. To find the limit of the function, look for the x value in the graph. If that x value has values approaching it from both the left-hand side and the right-hand side, and those values are equal, then it has a limit. Its limit is its corresponding y value. If the x value has no approaching values from either side, or if its approaching values are not equal, then its limit does not exist. Find the limit of f of x as x approaches negative 3. At x equals negative 3, the graph shows that there are approaching values from both sides. The approaching values are also equal to the corresponding y value. Therefore, the limit of f of x as x approaches negative 3 is equal to 1. Example number 4. Find the limit of f of x as x approaches negative 6. At x equals negative 6, there are approaching values from both sides, but the approaching values are not equal. Therefore, the limit of the function does not exist. Example number 5. Find the limit of f of x as x approaches 0. At x equals 0, the graph shows that there are approaching values from both sides. The approaching values are also equal to the corresponding y value 0. Therefore, the limit of f of x as x approaches 0 is equal to 0.
Abstract. To find the limit of a function using a table of values, we simply substitute values that are getting closer and closer but not equal to a particular x value. Find the left-hand side and the right-hand side limits of the function. If the limit exists and are equal, then the limit of the function exists and is equal to the left-hand and right-hand limits. To find the limit of a function using its graph, we analyze the given graph. If there are values approaching the particular x value and the values are equal, then the limit exists and it's equal to the corresponding y value. If there are no values approaching the x value, or if the values are not equal, then the limit of the function does not exist.
Thank you for watching this video. We hope you learned a lot. Thank you and God bless.